Alright, physics video. Yeah, so I have to do some demonstrating, so I won't do the live room for this, but I'll have a live room where I'll request somebody to make a counter argument to this argument. So anyway, metamorph. Known from unrelated subjects, but anyway, did some maligning of my physics. Nothing specific, just this whole general idea that some nobody could ever see anything or think anything of value. That only these professionals can know the truth. It's too complicated for anybody else to figure out. And blah, 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 blah. Well, anyway, so somebody asked him for a video recommendation. He recommended this video on physics as some sort of good example of physics at its best. And it is, in fact, physics at its absolute worst. It is horrible crap. And so I've played it before, and I'll play it again. And, you know, it's hard not to just make fun of the antics of these clowns. I mean, he calls me a clown. These are clowns doing physics. Patronizing, pretending they know something, and there's no way this audience can know it, so I'll explain it in little silly putty. And I'll do it with complete mischaracterization. So distant from reality that you can't call it anything but a lie. It's so distant from reality. I mean, it's either a preposterously imbecilic ignorance for a physicist to be this ignorant and still have a physics degree, or if they know the truth isn't anything what they're saying, it's just lying. There's no other way to look at it. It's horrible physics. It's horrible science. It's not science. It's rubbish.
Experiment that really gets the ideas of quantum mechanics across is the double-slit experiment. And I don't know, did any of you go to Spooky Action last year, just by any chance? Yeah, so a handful of you. So you may recall that we actually did the double-slit experiment on the stage last year. We're not going to do it again this year. We don't have enough time, but rather... Yeah,
well, it doesn't take any time, actually, right? I mean, you could already have it set up and just... There it is. So, so the experiment is this. This is the double-slit experiment, right? The little thing in the middle, two slits. And there's a thing called the single-slit experiment, which is, yes, the same thing. And the pattern for the single-slit experiment is this, and the pattern for the double-slit experiment is this. So I'll be getting back to that. But it's got nothing to do with this nonsense.
Animations will give you the essential ideas. And if anyone doesn't believe the animations, just ask someone whose hand was up, because they saw the real experiment done.
Again, the real experiment done, the experiment they should have done was the single-slit experiment. Because that's the one that's a little hard to explain, especially for them.
Last year. Okay, so what is a double-slit experiment? The idea is this. Imagine that I have a gun that's firing ordinary pellets, like BBs, at a barrier that has two openings. Now you'd expect that those BBs that go through the left slit will land aligned in a band on the left. Those pellets that go through the right opening will land in a band aligned with it on the right. And indeed, were you to do this experiment...
Right, if you were to do this experiment. Now, so this is a physicist, right? So we're talking about people who are supposed to know this whole nuclear thing. This whole idea that there's empty space inside of atoms, and it's this frictionless environment, and there's this thing called charge, and there's all this other kind of stuff going on inside of these atoms. And this they're going to use as a metaphor to photons traveling through material substances that are mostly empty space and interacting with what they know to be primarily electrons. But this is how they're going to metaphor that. The nuclear physics in the frictionless empty space somehow is relevant to this experiment in a medium, in a world where there is no charge, there's no, gravity's not relevant. All the forces that are strong and relevant on the nuclear level are weak and irrelevant on this level. Fair cop? No, idiot.
That is the result that you would find. Now, what we're going to do is imagine dialing down the size of those pellets, those BBs, making them smaller and smaller until they are the size of little tiny particles. Let's just call them electrons. Imagine we're doing this with electrons. Well, you'd expect...
So, the experiment, the Young experiment, was done with light. They ought to just stick with light. Electrons are charged particles, so, you know, not a brilliant idea to use something that actually is trying to go somewhere, not where you shoot it. Yeah.
That if you run the same experiment, again, those electrons that pass through the left opening will land in a band aligned with the opening on the left, and similarly for those that pass through the right. That is what you would expect should happen.
Right, but if you were a scientist, a physicist, you would already know that if I had only one slit here, that I wouldn't get this pattern. I would get a bunch of patterns. I would get an interference pattern, an on-off pattern. I would get this pattern. Now, this pattern will look like this. I mean, it'll look a lot smaller if you zoom in on it. Right? It doesn't look like much of a pattern anymore. But, you know, if you look at it at its full size, it's a strong pattern. And that just has to do with the width of this slit. So one of the things they do, this is a common trick. I mean, it's just used all the time by people who want to exaggerate the effect. What they'll say is well, the two-slit is completely different. Because they'll use the opening size of this for the single slit, and then they have this twice as big opening when they do the double slit. And then they'll compare those two results. And those two results will be different in the sense that you won't be able to see the pattern. See, the smaller you get, the more this pattern spreads out. So it gets bigger and bigger. It all stretches. So you can just imagine that just like this camera moving in, it stretches right out of view if you make the slit small enough. So if you make the slit small enough, there's no pattern. So that's the game they play, is they don't show the two experiments side by side fairly, which is single slit with the same aperture total opening. So just add up these two and equals to this total, and then you have the same number of photons, and then you can compare the two results and you'll see they're quite similar in the number of bars. This stuff is a whole nother thing that he doesn't going to show anywhere in here.
I think as many of you are familiar, this is not what happens when you do this experiment. Instead, if you do this experiment, you get results that look rather different. They look like this. You get a bright band next to a dark region, next to a bright region, next to a dark region, next to a bright region.
Right, on, off. Wow, the simplest pattern, I think. I don't think there's a simpler pattern you could possibly create in nature. As patterns go, it's about as simple as you can get. On, off, on, off, on, off. Simple, I don't think there's anything simpler.
Region, and so forth. And that data, that strange data, is really what impels us toward quantum mechanics. Now that data is...
Yeah, that data, again, that data is exactly the same data, except for this central maxima being twice as large. So you see how this is twice as big, and it'll be 8 times brighter in the single slit experiment. Well, quite obviously, because the middle of the slit is much bigger, so the opening of things not being interfered by these surfaces is going to be larger. So obviously this is going to be brighter right there in the middle. But that's the only difference between this and this. Same bars, same distance between the bars. The only thing that's different is this is brighter. That's it. Single slit.
Is strange because it's not what we would think should happen. We expect to get 2 bands and we get more. But it turns out that that pattern bright, dark is a familiar pattern to most physicists. I mean, we are trained from birth to recognize that pattern, right? If you were to...
So it's almost like saying we're trained to recognize the Pope as the head of the church or something. Again, it's the simplest pattern you could imagine that you could call a pattern. Can't get any simpler and call it a pattern. And they're going to just assume it means waves, when it could mean lots of things can create patterns, especially a simple pattern.
Go to any physicist, 3 o'clock in the morning, shake that physicist, wake them up and tell them, I got this data, bright band, dark band, bright band, dark band. The very first thing that they would say to you is, what the hell are you doing in my room at 3 o'clock in the morning? But after that, they would say, I know what that is. That's an interference pattern. That is the hallmark signature that there's some kind of wave phenomenon, taking place, right?
Right. So again, it's the simplest pattern, and yet they're going to assume it has something to do with a complex product. That it's the result of some sort of complex interaction between different things that are causing interference, which are causing things to be pushed one way or another. When you don't need anything complicated. All you need is something that basically the rule is that if the photon was going to go here, it goes here or it goes here instead. All you need is some rule that says by a certain percentage it will be deviated. All right. Well, there's so many other things.
To understand that, let me just give you a little visual here where we're looking at water waves. Imagine I throw 2 pebbles. The first one over here makes these circular ripples. I'm now throwing a second one, and look what happens. When the waves overlap, in some regions they work together, but in other regions the peak of one wave is crossing the trough of another.
Right. So this is about peaks and troughs. The waves are in here actually. So this is a double peak and a double trough and a double peak and a double trough, and this is where the water doesn't do anything. So this is going up and down. It's not doing on and off here. So this is the place where it's off. This is the on and off. And obviously too, these widths are kind of not even close. These are supposed to be the same width. The offs are supposed to be the same width as the ons, which isn't consistent. And the biggest gripe I would have in an obvious sense is that the frequency of these bands as they project outward, light has a tiny wavelength. This interference pattern should be intense at the slits themselves, and you should have so much interference. That the waves should be the distance of this target is really far, meters away from this tiny slit. And yet this interference pattern barely makes it to this great distance, over this great distance. So you can't really make that make sense as a bubbling wave in front of these slits, because the wavelength would mean that the band should be way out here, not so close together, so far away. Look how spread this is, just over a few feet, with a water wave. And we're talking about light.
Causing the wave to cancel out, and those are those dark regions that you see on the screen. So this is exactly the kind of data that we're encountering, and to make that point a little bit more clearly.
Well, see, it's not exactly the data they're encountering, because you can also see that the width here is getting very wide.
Let me just show you an animation, same idea. Imagine you've got water waves going toward the barrier with the 2 openings, and again, regions where the waves work together, the water is very agitated. Regions in between where the peak of one wave crosses the trough of the other, they cancel each other out.
Are the trough and the peak. But again, just understand that this has nothing to do with this wave being a peak. This wave goes down also, so this has to do with a wave that's going plus to minus. And this is the zero state. So it has nothing relevant to do with a photon in the sense that photons don't have plus and minus states. It's just silly. But anyway, this again, will happen with a single slit. So just take this away and then explain where the two waves come from. Where do you get your interference pattern? The pattern happens. Single slit, no interference pattern.
Out. And if on the back screen I put bright regions associated with very agitated water, dark regions with not agitated water, look what I get. Bright, dark, bright, dark, bright, dark. And again,
the simplest pattern in the universe.
To remember, that is the data that we find in this experiment. So this suggests...
Okay, now if I took a single slit and put a wave, water wave through it, I won't get that data. The single slit in a water wave will not produce this. It will just produce a wavefront. That's it. No interference pattern with a single slit in a water wave. Nothing like water waves.
That there is some deep connection between these particles, these electrons, and this other idea, a completely separate idea of waves.
Now, this is the implication. So there's this deep connection, as you just said, deep connection. This is a shallow connection at best. It's barely a tangential connection. And there's plenty of room for other explanations besides committing to some notion that particles are waves. No need to do that.
At first sight, that might not actually seem all that surprising, right? Because water has water waves, but we all know that water is itself made of little particles, molecules, H2O molecules. So certainly we know that if a large collection of molecules behaves in a choreographed manner, those particles can yield a wave. So maybe what's going on in the experiment...
They can transmit one. Yield is kind of a bullshit way to say it.
And is just that. You've got a lot of electrons, and maybe they are behaving in a choreographed manner, and that way yielding a wave just like H2O molecules yield a water wave.
So this is just another way of saying, look, maybe two photons go through the slit at the same time, and they interfere with each other, two different photons. But even that's silly. Interfere how?
Now how would you test that idea? Well, you can run this very experiment, but only firing particle by single particle at this barrier with the two openings, and recording dot by single dot where each of those single particles lands on the detector screen. So
right, and the simpler thing to do would just be to aim something at the two slits. So find something you can aim, and aim it at random, at the appropriate density for all locations of the openings, and shoot the same number of photons at each location. And you'll know exactly where they went, and you'll find out that it's the surfaces that are diffracting the light, and then all this woo can end.
let's run that version of the experiment and see what happens. So again, particle by single particle, we're recording on the back screen the history.
Again, the only way they do this experiment is they randomize the gun. They don't pay any attention to where the thing they're throwing at the two slits is, and they just throw this crap. And this whole description, of course, none of this is accurate. This is many times distant away from these two slits, and these two slits are microscopic almost by comparison to the target. I mean, they're one of these little dots wide by representation.
History of all the landing locations, and this is what happens in this experiment. Dot by single dot, we build up the same pattern, the same interference pattern, the same data.
Right, and again, the same data will be achieved if you take the size of that opening and the size of that opening, just combine them into a single slit. You'll get the same data, except the center will be twice as wide and 8 times brighter. That's it. The only difference. And obviously it'll be brighter because there's no impediment in the center blocking the light that would go straight through. Obviously in the two-slit experiment, the light going in the very center is blocked and never gets to the target. Obviously.
That suggests to us that there must be some kind of wave-like phenomenon involved to yield.
Right, some kind of wave-like phenomenon. Again, they just keep arguing that it's the simplest pattern in the universe, and yet we must conclude that it must be like water waves. We can't possibly conclude that they're very small particles, generally speaking, moving through fields that we understand to exist, that have charge and that will move particles, generally speaking. And certainly when photons interact with electrons, they will leave, perhaps, not going the same way they were going. They'll be changed in their direction, depending on the movement of the electron.
This interference pattern. So this is where things get really strange. Particles, electrons, little tiny dot, that is the image that we always have in mind.
Right, well again, that's your image. So again, this is the professional physics image of an electron. An electron is something that's storing energy, E equals mc squared, and yet we're going to call it a dot. It's not really kind of sensible, is it? It produces photons more than we think anything else does, as electrons absorb and produce photons, and yet we're just going to call it a dot. It's obviously a dot that has a mechanism. Yes, electrons have a mechanism. Maybe you should look there for your wave.
Waves are these spread out entities. How could a dot particle and a spread out wave somehow be connected? And this was...
They can't, and that's why physics is on the wrong road. They call it the electromagnetic spectrum, and they put photons on it, light, and they put radiation, they put radio waves, they put all this stuff on it, and there's absolutely no evidence that any of these things, alone in space, have any electro or magnetic component. They don't produce any electricity, they don't produce any magnetism unless they interact with an electron. So it's not until they hit an electron that they have any magnetic or electric component. They don't give off any in flight, like an electron would.
It's a puzzle that physicists faced in the early decades of the 20th century, and many tried to figure out what could the connection between a particle and a wave be. And the natural suggestion that you might throw out is, maybe particles somehow are kind of smeared out in some way. They're kind of spread out in a way that we didn't realize. That idea, though, doesn't really work, because whenever you measure an electron, you find all of it. And if it was truly smeared out, you find a piece of it here and a piece of it there.
Right, so it can't be a wave, and it doesn't make any sense to consider it one anyway. A wave isn't moving billions of light years through space. It's not a sensible description. Waves are in mediums. They're not in empty space. It's just not a very good way to describe something inaccurately.
And the idea that ultimately was settled upon, it came from the mind of a physicist, Max Born, was that the way to think about the wave associated with a particle is this. This is the new idea. The wave is a wave of probability. The wave is telling us the likelihood, the probability that the particle is at one location or another. So to show you a little visual of that, imagine this is the wave associated with a particle like an electron. Where the wave is big, that's a likely location to find the particle. Where the wave is small, an unlikely location. And where the wave is absolutely zero, that is a place where you simply will not find the electron at all.
Well, it doesn't really have anything to do with the single particle. So again, it's over. If you're gonna randomize your production of something, then you're going to have to deal with the fact that you have created things that are in different positions. But the bottom line is what's changing where the light ends up. I think obviously, just by this simple observation you can make between these two experiments, double slit, single slit, the fact that this central bar is twice as large and 8 times as bright, and this is wide open here, and then this is blocked, and this one isn't. This one's 8 times duller and half the size. Doesn't that tell you something enough right there to tell you that photons going through the middle of the single slit are pretty likely to end up here? I think so.
That's the picture that comes forward. Now, how would you test this idea to see if it's actually describing in reality how the world works?
Do a single slit experiment. Yeah, then you'll find out that none of this wave crap is necessary.
Well, the first thing is you need some kind of mathematical equation that allows you to understand how this wave evolves, how it changes over time. And that equation came to us from Schrodinger. Whether you understand the mathematical symbols or not, it doesn't matter, but it's good to see that there is a bona fide, rigorous mathematical equation behind all of the imagery that you will be seeing here.
Yeah, whatever. A bona fide equation that has pitchforks in it and, you know, whatever. Lambdas and bibble babble. Okay, never mind.
Tonight, that is the equation that describes how...
And that equation doesn't describe this at all. That equation doesn't explain why does this pattern get lighter. So this is drawn just to illustrate that by size that this gets duller and duller and duller. So it's bright here and it gets weaker and weaker and weaker and then to nothing. And then it starts getting brighter again and then goes to nothing. And then it gets brighter again and goes to nothing. That's the pattern of the double slit experiment. This bar pattern ends up doing this. That's not in their math anywhere. This equation doesn't reveal this pattern.
This wave,
Their equation says this is what it looks like. It doesn't look like that.
probability wave evolves over time. That's step one. So now you understand how things change in time. But to test it, well, you say to yourself this. Look, if at a given moment in time I've got this probability profile for where a particle should be located, the way I test it is I run the experiment of searching for the particle over and over again in identically prepared situations, and I count up the number of times I find it in one location or another. And if the theory is correct...
There's no such thing as identically prepared situations, so that's bogus right there.
You should find the particle more often where the wave is big and less often where the wave is small. So we can run that little experiment right here. So this is a simplified probability wave, the blue curve, and each of the x's is the result of an experiment looking for the location of a particle. And you see over many, many, many runs of the experiment where you record all of the locations where you find the particle, over time, they fill out exactly the probability profile that comes from the mathematical equation. And that agreement between experiment...
So we don't even know what that experiment is. I mean, obviously it does have an irregularity in it, in that this big loopy thing here. So, but yeah, I don't know what experiment exactly that is. So, can't say much about it. Obviously something's causing, cause and effect universe, fellas. I mean, that should be like a premise of physics, is let's stick with cause and effect unless we really, really, really have to get rid of it.
And theory is what gives us confidence that these ideas are actually describing how the world works. So just to kind of close the loop on this, going back to the double-slit experiment, how...
Right, that little pile of crap had absolutely nothing to do with...
We describe it, well, in this new language, the electron should be thought of as a probability wave which hits the barrier with the two openings, and much like a water wave, when the wave goes through, it interferes, creates this pattern of wave locations where the wave is big or where the wave is small.
Right, again, no two slits are necessary to create the interference, so again, where do your two waves come from?
And those locations...
Huygens, the made-up principle that's not applied anywhere else in the universe, that creates an infinite number of little wavelets, an infinite number, physicists using infinite. That doesn't make much sense.
Dictate the likelihood or not of an electron landing in one of those regions. So now if we run the experiment with the little particles going out, dot by single dot, they're going to fill out that probability profile. Where the wave is big, there are going to be many electrons landing.
Where they mean where the wave is big, they just mean when they do their probability math of their, let's see, how do you even put it? When they put in the numbers of the width of the slits and the width of the dimension of the middle impediment, which is much smaller than this illustration, then they'll get this number for the probability. And again, it doesn't explain this. No explanation whatsoever for this change, which coincidentally you can sort of understand to be when I zoom in on this, I start to create that very kind of thing. This is basically on, off, on, off. So I'm creating another version of the on, off, and I just have a double one in the middle. A double on in the middle.
The wave is small, very few, and where the wave was zero, the dark locations, no locations will be occupied by an electron at all. So this is the basic reason why we believe that these ideas are correct. So what this means is...
And again, they're using electrons in this experiment, which is also kind of, like I just said, you should just stick to photons. That's what the original experiment was done with, because we know photons do travel rather straight, where electrons do not.
By year 1930 or so, these individuals, the pioneers of quantum mechanics and others as well, these are, we have over here Max Planck, we have Albert Einstein, Niels Bohr, Werner Heisenberg, Robin Williams, Erwin Schrodinger kind of looks like Robin Williams there. So these fellas here developed this structure which seems very odd, but able to describe the data. Okay, so
again, let's just understand, it doesn't describe the data. It doesn't describe this pattern at all. It just doesn't account for any part of this at all. The superposition of two wave patterns on top of each other. It doesn't explain.
That's the good part of the story. Now for the question that will occupy us here tonight, which is this. When we talk about, say, the motion of a particle like an electron, we describe it in this wave-like manner. It could be at one location or another still. But when we actually measure the electron, we find it at one single location. When we find it at one single location, we know where it is, which suggests that it must be the case that the probability wave has now spiked at that location because we know where the electron is. The problem is...
And again, this just all depends on this idea that, we don't have the capacity to view very small particles. So we can't do this in any kind of scientific way where we could explicitly view them and then recognize where they are, like they're a car going down the street, and then just take a moment of time and say for that interval of time it was in this location. Obviously for a moving photon, an interval of time is a tiny amount of time. It's moving really, really fast. So yeah, it's really small and it's moving really, really fast. No chance you're going to be able to know exactly where it is through any kind of experiment. But the fact that it is somewhere is a fact. And it has nothing to do with any kind of probability. It has to do with an explicit reality. It is in a certain location and it is moving in a certain direction. Those are facts.
Notion of the active measurement affecting the probability wave in that
There's no such thing as the act of measuring. So understand, the act of measuring means that the photon goes into something, gets consumed, and then is shat, is returned to the environment in a somewhat different form usually. But there's no such thing as a photon being in any way subtly interacted with. It's either absorbed by an electron or not. It can't push something or move something or do anything to anything unless it interacts in that manner. It has to be absorbed and readmitted. That's it. It has to go into the orbit of the solar system and fly out in some other direction. That's the only way it can interact. It can't interact in any subtle way where it flies next to the solar system and still moves the solar system. That can't happen.
Manner does not agree with the mathematical equation. So we'll talk about this in more detail in just a moment. In fact, when you look at the mathematics, or in fact when you think it through, even just recognizing that when we make an observation, we use a piece of equipment, that piece of equipment is itself made up of the very same particles, electrons and protons and neutrons, the same particles that we use the quantum language to describe. And therefore, if we have a situation, say, where the probability wave for an electron has...
This antics, this gyrating.
Some non-trivial value in one location and some non-trivial value in another location, and we go to measure the position of that particle, well, the measuring equipment should be sensitive to those two components of the probability wave, and therefore, in some sense, should register both of those outcomes at the same time. And that is something that never happens. We never look at a measuring device and somehow it is confused.
Whatever. Duh. Because again, there's no such thing as a measurement. There's a termination and a readmission.
In giving us information about the location of a particle. That is the quantum measurement problem. How do we go from the spread out probability wave, which tells us a particle can be here or there or here or there, to the single definite reality that we all experience? How do we navigate from the place of probability to the place of definite reality? That is the question. And thankfully, we have some of the world's experts joining us here tonight to describe various possible solutions to that puzzle. So, without further...
Right, and so again, there was no mention of single-slit, and now they're going to play a dart game and explain that the dart has radar, so that's one theory. So the dart radars, looks at the circumstance and then decides where to go, and the other one is that every time a photon goes through a slit, a new universe is created. A bunch of them. So yeah, just nonsense explanations. So horrible videos, slop, nonsense, gibberish, garbage. So anyway, the premise is wrong. Their math doesn't describe the reality. Huygens is used for this. So they come up with a principle that they only use for this one circumstance that basically says an infinite number of little waves are made here, and all of them annihilate each other except for this one and this one. And now these two waves are the ones that create the interference pattern. Now isn't that incredibly convenient? So the single slit creates two waves, two photons that end up creating this pattern. Now, they don't use that same exact principle here because then they would end up with 4 waves, and they'd end up with a different pattern. They'd end up with the 4-slit pattern, not the 2-slit pattern. So they can't use their principle in this circumstance. So somehow physics, somehow photons know when it's a single slit, and they say, okay, time to Huygens. And when it's a double slit, they say, no, no Huygensing allowed. No principle here, because it'll fuck up the math. I mean, it's bullshit. And they ought to be called on it. Somebody with professional credentials should be doing this, because this is crap physics. He's taking a crap on science right there. That's what he's doing. He's crapping on the truth. He just crapped a huge pile of bullshit. It's crap. The whole premise of physics, their underlying experiment, the foundation of their conclusions about this whole wave-particle duality, all of this nonsense is based on crap. So, yeah. Counter-arguments. Based on a fact somewhere. Show me a fact. Yeah, somewhere. But there won't be any such facts. Because what I've said is the truth. They're mischaracterizing reality, and they're cheating whenever their math doesn't work. Huygens, dark matter, blah, blah, blah. It's all just fudge. It's God of the gaps crap. That's what physics is. It's just another religion. So, fuck this guy. I'm going somewhere else. So, see. Till next time. So, next time. There's no counter arguments. I'm right. And Brian Greene is full of shit.